So I was talking about the structure of glucose, that is C6H12O6. This C6H12O6, that is C6H12O6, it means CH2O6 times. Since it is CH2O6 times, we cannot take it for granted all the CHOs are carbohydrate. For example, let me have CH3COOH, and it can be written as C2H4O2. So you can put CH2 then twice. Now can you argue that this is carbohydrate? No, this is acetic acid. So from this, one point is clear: all CHO repeated units cannot be taken for granted as glucose or fructose or saccharides. Now let me consider this structure, that is, this should be C and this is C. So CHO, CHOH, 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 then CH2OH. When we start counting from here, 1, 2, 3, 4, 5, 6. Okay. So here, or it can be counted like this, because this is the potential function group. So we should consider this one so that the numbering should be in this way. So you have to start from the top, okay, like as it is given here. So 1, 2, 3, 4, 5, and this is the 6th carbon atom, and this is the 1st carbon atom. So the 1st carbon atom is involved in aldehyde functionality. The last one is the primary alcohol. In between that, you have the alcoholic unit. And what are the types of alcohol? This is secondary alcohol. Why? Because CHOH, and this is also CHOH. Okay, so secondary alcohol, secondary alcohol, secondary alcohol, secondary alcohol, and this is primary alcohol, and this is the aldehyde. Do you understand? So likewise, we have to analyze this structure. And not only that, in the third group, the CHOH is just occupying, it has just interchanged its position, where it is in the third position. Otherwise, all OH group will be on the right side only. So they are basically dextro-rotatory. In optical activity, we have already discussed about this. Optical activity means what? The phenomenon of rotation of optically active, that is polarized light by the optically active solution. For instance, normal light will be vibrating at perpendicular direction, perpendicular plane. You can put it as a perpendicular plane. So when the light is progressing in this way, it will be vibrating like this, up and down, and here. So here likewise in the perpendicular direction. Let me select this light and this vibration and this vibration. When it is subjected, when it is passed through an optically active solution like sugar solution, they are split into, that is, actually it is not optically active solution. This is called Nicol prism. It's a kind of prism that can split the polarized, plane, normal light into plane polarized light. So the vertically vibrating light will be separated from the horizontally vibrated light like this. And these two sets can be called plane polarized light. What is that? Plane polarized light. When such, let me take this one. So when such plane polarized light is passed through optically active solution like sugar, what happens is it may rotate either in the, so we expect normally in this way. But instead it will rotate like this. So there is an dextro rotation, that is right side rotation. So this is called the optical activity. Are you able to understand? So what is optical activity? When the plane polarized light, that is this one, when the plane polarized light is passed through optically active solution like sugar, they get slightly rotated either to the right or left side. If the sugar is rotating this plane polarized light in the right direction, they can be called dextro. So dextro rotatory sugar, and such type of sugars can be called dextrose. Are able to follow? Os means sugar, so dextrose. So similarly, levo rotatory, LAEVO. This is minus, this is plus. Do you understand? So towards right, towards left. This is called optical activity. So, and basically, we will be discussing about the rotation also in the sugar. And before that, we will try to understand the structure in a very simple way. Write down. So this is aldehyde, first carbon atom, second carbon atom, third carbon atom. As I already suggested, third carbon atom will be positioned like this, the HOH, and otherwise they are HOH, and this is HOH, this is HOH, and this is CH2OH. So as I already mentioned, this is the first carbon atom, second carbon atom, third, fourth, fifth and sixth. Okay, please take down. And this is called the potential aldehyde group. As I already mentioned, these parts are secondary alcoholic. And what about this? This is primary alcohol. You may ask me, sir, whether such a compound will be that is giving the reactions similar to secondary alcohol. Truly speaking, yes. And what about this? Yes, this will also exhibit the property of primary alcohol. And what about aldehyde? Yes, it will. But you should understand that after studying the complete structure of alcohol, there are some drawbacks also. So let me, before going to that, you try to copy this.
Sir, ஒரே பாட்டில் டெக்ஸ்ட்ரோரேட்டரியும் ஈவோரேட்டரியும் சொல்லுங்க சார்.
Dextro means towards right, levo means towards left. So when the plane polarized light is rotated in clockwise manner, then it is called dextro-rotatory. When it is anti-clockwise, that is counter-clockwise means, then it is called levo-rotatory. That's all. Okay?
Yes.
Right. Now we have the same glucose can be drawn as a ring structure also. Let me explain how this is possible. For instance, we have got that ring structure, is it not? And this ring is made up of how many carbon atoms? Let us identify. First carbon atom 1, carbon atom 2, carbon atom 3, carbon atom 4, carbon atom 5, and this is the heteroatom 6. So this is the 6-membered, what is that? 6-membered ring, which is similar to the pyran. So in the case of a pyran, we have the structure, so it should be like this, pyran, and actually that is pyranose, it's called pyranose. Okay, so it is similar to that is this pyran ring, and that is why it's called pyranose. Similarly, we have furan. The furan ring structure will be a 5-membered ring like this. So this is known as furan, and structure similar to the 5-membered ring can be called furanose. Actually, fructose is a furanose, whereas a glucose is a pyranose. Now let me explain about this, how this pyranose ring structure, the hemiacetal ring structure, is formed. So we have, let me go back once again here and look at this. This is the potential aldehyde group. Let us remove it. Okay. Now let me have, this can be written, CHO can be written as C double bond O and H. So we know very well there is a pi electron transfer, so it becomes delta minus. And particularly this 5th carbon atom, the hydroxyl group attached to the 5th carbon atom, it can form a hemiacetal ring with the 1st carbon atom. Okay, so this, and in this case this hydrogen. Okay, so they can interact. Okay, so to form a compound C and then OH. This will form, it forms a OH, and it can draw a structure like this. First carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom, sixth carbon atom. Okay, let me have this one. So this OH and here it will interact. To form a oxy linkage like this. Okay, and the remaining atoms can be written as, that is CHOH as here, CHOH 1 2 3 4. So 1 2 HOH, third carbon atom will be OHH, fourth will be HOH, and fifth carbon atom OH is involved in the hemiacetal ring formation, and here H, and this is CH2OH. Okay, so we have a justification for this hemiacetal ring also, and I will discuss under the elucidation of glucose, but try to remember this structure. Okay, have you drawn? Now what you do is you just look at the structure. So O is here and the CHOH. So this is the, which is the first carbon atom, this is the first carbon atom, this is the sixth carbon atom, is it not? So we can mention like this, this is the first carbon atom, okay, and this is the sixth carbon atom, this is the fifth carbon atom. So there is an interlink between 5 and 6, there is a link, oxy link, ethereal link between first carbon atom and the fifth carbon atom. Are you able to understand? So you can draw this is called Haworth synthesis, another structure of glucose. Are you able to follow? So you can draw like this, you can convert this structure. Let me draw this, listen to me. here, 5th carbon atom, 6th carbon atom, and then there is a linkage between that. So this is the first carbon atom, that is this one, and you can write as HOH. So the remaining part can be easily written. This one, draw a hexagon, that's all. Okay, so you can put, if you want, you can put C. Okay, and this is CH2OH, that is the 6th carbon atom. Let me complete. And this is H, and this one is now CHOH, and here HOH. This is the 2nd carbon atom. Remember, 3rd carbon atom, that is OH, should be kept here and hydrogen here, and 4th one, that is H and HOH. Okay, so this is a structure, that is the Haber synthesis of glucose. See, you got the glucose like this. Let us assume, you just look at my hand. So this is a vertical setup, is it not? OH. You just turn it like this. Are you able to understand? You just turn it, so you can fix it. Okay, so CHOH, etc. Make a link. Then we can draw the another structure, that is it is almost similar to our cyclohexane. What do you call this structure? Is it a boat form or chair form? Anyone? This is a chair form like structure. Yes. So how to draw the chair form? You can draw like this. Okay. Draw a parallel line and put, that's all. Okay. So here oxygen is there, and similarly you can put oxygen here. That is the oxy link. And in between on the OH, so you have to draw the HOH like this. And here, so there are two types of bond, axial bond and okay, so it will be like this. And this is another, flags. And then so this is the last one, CH2OH can be written like this, CH2OH. Okay, so refer this structure. So these structures can be called the Haworth structure, and we have two types of glucopyranose. Let me explain about this. So draw this. This is known as glucopyranose, and this can be called alpha glucopyranose, beta glucopyranose. Okay, so what is that? Alpha glucopyranose, then beta glucosepyranose. This nomenclature arises because of the rotation around the potential carbonyl compound, carbonyl group. So this CHO, CHOH, that is rotating. Okay, so it results in, that is, in this case, when the OH group is on the lower side, this is called alpha. When it is shown in the upper side, then it can be called beta. Do you understand? Otherwise, everything remains same. Okay, so based on this potential group, the nomenclature varies. So here it is alpha D plus. Okay, so don't put minus, these are all only hyphen. So I would suggest you can simply put alpha, better put D means dextrose, and then put plus, then glucopyranose. Okay, don't put this hyphen, you may get confused. So this is alpha D plus glucopyranose. Similarly, beta. So beta, don't put hyphen, better put D or D plus, beta D plus, beta D plus, and then glucopyranose, or you will follow pyranose. Okay. Have you noted? So this Haber's structures. So the rotation around this potential aldehyde group, okay, that results the alpha beta structures of glucose. Got it? Right. Now we will elucidate the structure of glucose. We need to justify, or we have to show the evidences of the structure for glucose. This is called structural elucidation. Take down. Structural elucidation of glucose. Now, see Aldo Hexose. This has already been explained, the glucose as Aldo Hexose. So Aldo means it should have potential aldehyde group and the function as potential function group. Then hexose means 6 sugar should be there. So the molecular formula is, that is C6H12O6. From the molecular weight determination, so we can find out the molecular weight. What is that molecular weight determination? Like as I already discussed under colligative properties. What is colligative property? Anyone? The properties, the physical properties of solutions may vary with respect to the amount of solute present, is it not? Like elevation of boiling point, depression of freezing point, then relative lowering of vapor pressure and increase of osmotic pressure. So elevation of boiling point, let me say delta TB, that is proportional to what? The number of moles of solute, is it not?
Yeah.
Number of moles of solute, the amount, that is very important. And the mole is nothing but weight of solute divided by molar mass of solute. So in that case, by knowing in fact the delta TB is the experimental value and we know the other values, and based on that you can find out the molecular weight of the given substance, is it not? It is a fantastic technique, and that is why such type of colligative property experimental studies are called molecular weight determination studies. So based on that we can find out the molecular weight, and once you are able to get the molecular weight, where from we can get the empirical formula. Once you are able to get the empirical formula, we can get the molecular formula, and that is a great excellent route to determine the molecular formula. So based on this, we were able to find out the molecular weight, formula of glucose based on these experimental studies and instrumental studies. Now our idea is we have to establish the structure for this glucose. How we can go about? For instance, that is when this glucose is heated with hydrogen iodide, it forms hexane. So it is a direct proof that it consists of 6 carbon atoms, and that too in the straight chain. So that is the point number 1. Do you agree with me? When it is hexane, it is pretty clear that it consists of 6 carbon atoms. Okay? So all these carbon atom in glucose, it is a straight chain, it is connected together. So that is point number 1. Now let us move to the next one. When we react this with hydroxylamine, can anyone tell me the molecular formula of hydroxylamine? Anyone? Try to speak something, whether it is correct or not, don't worry about that. Hydroxylamine, NH2OH, hydroxyl group OH, NH2 is amine, so hydroxylamine, so NH2OH, okay, hydroxylamine. So when hydroxylamine is treated with this the glucose, what happened was we were able to get, that is, oxime. So it indicates the presence of some aldehyde group there. Is it not? So we were able to get some aldoxime. So that indicates the presence of aldehyde group, and that is why it is a direct group for the presence of carbonyl group. So the carbonyl group is present, and not only that, when this carbonyl group is subjected to reaction with hydrogen cyanide, we were able to get the cyanohydrin compound. Cyanohydrin means any compound, for instance CHCNOH, this is called cyanohydrin. Suppose in place of cyanide, if you have got chlorine, then it is called chlorohydrin. Okay, so this is chlorohydrin, so this is cyanohydrin. So this type of reactions are possible only in the presence of CHO. So it is a direct proof that it consists of carbonyl group. So glucose consists carbonyl group. That is the direct witness, is it not? Direct evidence. Okay. Shall I move to the next one? Next evidence. So the next evidence was to prove that the presence of 5 hydroxyl group. So fortunately, we were able to get 5, that is look at the structure, 1 minute. Let us have this here. The oxidation of bromine water gives gluconic acid. So that confirms the presence of, we were talking about only carbonyl group, because this carbonyl group can result oxide. When it is aldehyde, it is giving aldoxide. When it gives ketoxide, then it can be ketone. So anyway, for oxime formation, the carbonyl group is present, but we do not know whether it is aldehyde or ketone. So in order to confirm that is when we oxidize, it was able to give you, that is, an acid, that is called gluconic acid. So without loss of carbon atom, so it means that it should be an aldehyde group. That is another confirmation. And after that, in order to show that it consists of 5 hydroxyl group, in the middle 4, and terminally you have 1. So totally 5 hydroxyl group. All these 5 hydroxyl groups are capable of reacting with acetic anhydride. What is the formula of acetic anhydride? That is CH3. What is that?
CO.
Actually CH3 COOH, 2 moles of CH3 COOH, acetic acid. So they can combine to form, on the removal of water, you will get acetic anhydride. So CH3 C double bond O O C double bond O CH3. So this is known as acetic anhydride. So when you treat this with acetic anhydride, we were able to get the acetyl derivative. Okay, so acetyl derivative means that it is a kind of, for instance, when you have got any OH, it can react with what? Such type of acetic anhydride. That is, you can write CH3 CO twice O. So when you are able to combine this, you can get O and then C double bond O, then CH3. This is called the acetyl derivative. You are able to get the acetylation product by treating with acetic anhydride. So we are able to get 5 penta O acetyl. It's called 5 penta O because this acetyl is formed through oxygen. So it is called penta O acetyl derivative. That indicates the presence of this 5OH group. Is it clear? So that is another important point to be noted. Okay, please take down. So with the structural elucidation of glucose, I will wind up this session. Shall we move to next one? Have you copied?
Yes, sir.
Right. So, and another thing is, we have found out 5OH group, but we need to distinguish, is it not, whether they are primary or secondary. So there is another challenge for us. Now let us meet out here. So on oxidation with nitric acid, gluconic acid is formed. We know already gluconic acid. It is the monocarboxylic acid. Got this point? So we get this monocarboxylic acid, gluconic acid. That is point number 1. And on further oxidation, we were able to get that this CH2COOH is also oxidized on further oxidation. Then we were able to get saccharic acid, that is the dicarboxylic acid. And so from this, it's obvious that, for example, from gluconic acid, we are able to get saccharic acid, and by oxidizing powerfully the glucose itself, then we are able to get once again saccharic acid. So it means that it consists of, that is, one primary alcoholic OH group. Is it not? So without affecting this, so it means that only terminally it is possible for us to get the carboxylic acid, and that to monocarboxylic acid. Okay, so it's clear it consists of one primary alcohol group. So we have already discussed about 5OH group, in which there is one OH is primary, and what about the other? The other 4 OH groups are of secondary nature. Now we were able to establish the structure. So this is the way we established the structure. So Fischer, he studied some spatial arrangements of this OH group. So here he put CH2OH, CHO, CHOH, but from here or from top third, so he has interchanged this OH. And in this case, now CH2OH, OH, and here OH, and then this is aldehyde, and this is carboxylic acid, and this is dicarboxylic acid. So what about this? The glucose, actually the saccharic acid structure has already been established, and that was one of the greatest clue for the rearrangement of this H and OH. In gluconic acid, we have already identified the rearrangement of the third carbon atom with the OH and H on the other side. Okay, so since we were able to get the gluconic acid by oxidation of glucose or oxidation from gluconic acid, okay, we were able to arrive at the structure that the glucose may have such type of structure, and thereby we have put all the OH here except the third, that is rearranged based on the structural aspect of the what? The optical rotation is also D plus, so that represents the D configuration, that is dextro configuration. And in this case, is it clear now so far? Any doubt? Now we have to establish whether it is D form or L form, and that has to be ascertained. So the DL configuration, the DL notation can be represented in this way. Right? Look at this. In fact, when I put the OH on the right side, then it is a D plus D configuration. When it is put on the left side, this is the L configuration. Okay, so the priority of atom, the lowest asymmetric carbon atom is on the right side. So this is according to the rule we have already discussed under DL configuration. Probably that is you can refer my lecture regarding RS notation and DL configuration. I have in detail I have discussed about this, and that video will be very useful to you. Okay, so based on that we were able to arrive at the D configuration and L configuration. Right, then now let me explain about this. That is, first of all, we should know something about the what do you call the asymmetric carbon atom before discussing all these things. Take down, what is asymmetric carbon atom? The carbon atom attached to different atoms or group of atoms can be called asymmetric carbon atom or the chiral carbon atom. And such type of compounds are having asymmetric carbon atoms will be optically active, and that is why now you look at this glucose. We are already this is glucose. So you have got 1 asymmetric, 2 asymmetric, 3 asymmetric, 4 asymmetric carbon atoms. Okay, so it is pretty clear that it is optically active. And let us look at this D plus glyceroldehyde. So here this is CH2OH, this is CHO, this is CHO. CHOH, this is CHOH. Okay, so now this is known as D plus glyceroldehyde. Is it not D plus? Because dextrorotatory. Okay, so in this case, similarly, the last the last two groups, CH2, that is 5th carbon atom and 6th carbon atom. So they belong to the dextro type. So it can be called D plus glucose. Now we need to prove the cyclic structure of glucose. So that is another important aspect. Let us talk about this cyclic structure. Let me take some more time. I will finish it. Now, so the cyclic structure, let us look at this. Here we have something about a hydrazine. What is the formula of hydrazine? NH2, NH2, is it not? So what is the formula of hydrazine? NH2, NH2. So this is called hydrazine. Please note, take down hydrazine. And phenyl hydrazine means you can replace one hydrogen by phenyl group. So C6H5NH NH2. So this is called phenyl hydrazine. Okay, take down. Now, when you have got diphenyl, what is that? Dinitrophenylhydrazine. So dinitrophenylhydrazine means in phenyl there is one nitro group and another nitro group. I hope now you should be able to understand this DNP. Is it clear now? So I have got the C6H5 group where I have got two nitro position, dinitro, then phenyl, then hydrazine. Got it clear? Right. So DNP, when DNP is treated with any, that is such kind of carbonyl group, we are able to get an yellow precipitate. It means it indicates the presence of CHO group. Okay, please note down this. So we have established that, listen to me carefully, the glucose has aldehyde group, but unfortunately in DNP test it has miserably failed. The scientists, they were wondered, they stuck with this great confusion. Why this absence of, that is negative result for this glucose even though it has the CHO group? If it is CHO group, it should give that yellow precipitate, but unfortunately they were unable to get that. So the absence of free aldehyde group, that is very, very important. So the negative test, it means no yellow precipitate. So that indicates that there is an absence of free aldehyde group. Are you able to understand? There is aldehyde group, unfortunately they are not freely available. But at the same time, it reacts with Schiff's reagent. So when butanone reacts with the Schiff's reagent and in presence of methanol, then we are able to get a red precipitate. And here there is no red precipitate. With the Schiff reagent, glucose gave a negative result. Okay, so it is the proof of that is there is no free aldehyde. So absence of free aldehyde. Okay, and not only that, it doesn't react with the potassium bisulfate, that is a very popular addition product with any aldehyde. So it means it doesn't have free aldehyde even though it has the CHO terminally. Okay, so these are all the wonderful results, and based on that they were able to arrive at the hemiacetal ring formation, that is the ring structure for glucose based on these experimental studies, and that is why it is known as structural elucidation of glucose. Now let me consider, let us have the hemiacetal ring. This is called hemiacetal ring. As I already mentioned, the first carbon atom, and there is an interaction with the fifth carbon atom, so it forms a bond like this. Okay, so and based on that there will be a free rotation of the COH group also. Okay, that is HOH, there will be a rotation at the potential aldehyde group, there will be a free rotation. So that results the alpha beta glucose, and they are called anomers. So what are anomers? Alpha glucose and beta glucose. So now when this glucose is, there is a change of structure from alpha to beta through this open structure of glucose. Okay, alpha to beta, there is an anomerization. Okay, so that this kind of neutral rotation occurs where? At the potential carbon group, that is aldehyde group. Okay, so in this case it is a less stable one. This is a less stable one. It acts as this open structure is unstable intermediate. Either it should form a ring like this or a ring like this. If it forms a ring like this, this is called beta glucose. If it forms a ring like this, this is called alpha glucose. So this is the ring structure of alpha glucose. This is the ring structure of beta glucose. And however, he suggested, that is this structure can be resembling the pyran, so we can exhibit it. This glucose can exhibit the glucopyranose ring, and thus was the structure of glucose arrived at. Any doubt?
Sir, switch base na?
No, sir.
Enama?
Shift base na, sir?
ஷிஃப்ட் பேஸ் தான் அந்த இடத்துல நான் சொல்லியிருக்கேன். ஷிஃப்ட் பேஸ் அப்படிங்கிறது இட்ஸ் அ கைண்ட் ஆஃப் தட் இஸ் ஒரு அது ஒரு டை மாதிரின்னு வச்சுக்கேன். அதோட ஸ்ட்ரக்சர் வேணால் நான் அப்புறமேட்டு தரேன். அதில் வந்து பேஸ் வந்து அதில் இருக்கும். அது ஷிஃப்ட் பேஸ் இட்ஸ் அ கைண்ட் ஆஃப் இண்டிகேட்டர் மாதிரி தான் அது. ஆமாம், ரெட் ஆகிடும். ஆல்டிஹைடாக இருந்தாக்கா ரெட் ஃபார்ம் வந்துடும். பட் இது ஆல்டிஹைட்னு சொன்னாலும் அதில் ஆகலை. இது ஏன் ஆகலைன்னு பார்த்தா அதில் ஃப்ரீ ஆல்டிஹைட் இல்லை, அதனால தான் அது ஆகலை. Any doubt?
No, sir.
ஸோ அந்த லாஸ்ட் ஸ்ட்ரக்சர் புரியுதா பாரு. அதுலேருந்து எப்படி வந்து அதை அந்த ரிங் ஸ்ட்ரக்சர்லாம் கொண்டு வந்தோன்ட்டு. ஷிஃப்ட் பேஸ்ன்றது ஒரு காம்ப்ளிகேட்டட் ஸ்ட்ரக்சர். அது வந்து ஒரு வி கேன் கால் இமைன்னு சொல்லுவோம். அதாவது C டபுள் பாண்ட் N வந்து வரும். அது you can simply write shift base. It is called actually simple aldehyde as a reagent, and this can be called you can call it in otherwise second note panika shift base or edha ketaka shift base is eppadi sollalam, that is ஒரு secondary ketimine அப்படினு சொல்லலாம். secondary கீட் இமைன், கீட்டோவும் இருக்கும், இமைன் குரூப்பாக இருக்கும். அது கீட்டோலேருந்து ஃபார்ம் பண்ண இமைன் குரூப், அமீன் குரூப்புன்ற மாதிரி இமைன் குரூப், செகண்டரி கீட்டிமைன். ஆர் இட் கேன் பி கால்டு செகண்டரி எப்படி சொல்லலாம், ஆல்டிமைன் அப்படின்னு சொல்லலாம்.
Okay.
ஸோ இந்த சேர் ஃபார்மில் அதனுடைய பார்ட் நீ தெரிஞ்சிருக்கணும். த சேர் ஃபார்ம் ஆஃப் குளுக்கோஸ். There are two types of bond, axial bond and equatorial bond. So you should be able to identify that one also. Take down. So vertical இருக்கிறதெல்லாம் axial bond சொல்லலாம். equatorialனா slanting-ஆ இருக்குல்ல அது. அது மாறி மாறி வரும். ஒன்று ஆக்சியல் பாண்டு டாப்பில் ஒன்று, பாட்டம். இப்போ இந்த ஸ்ட்ரக்சர் கொடுத்துருக்கேன்ல, நவ் திஸ் இஸ், ஸோ ஒன்று நவ் திஸ் இஸ் ஷோவிங் அட் த பாட்டம் இல்லையா, ஷோவிங் அட் த பாட்டம். இந்த ஸ்ட்ரக்சர் இங்கே போடுறப்ப ஷோவிங் அட் ஆல்டர்னேட்டிவாக வரணும். பாட்டம் டாப், பாட்டம் டாப், பாட்டம் டாப். ஓகேவா? ஸோ லைக்வைஸ் யூ ஹேவ் டு ட்ரா. அண்ட் வாட் அபவுட் ஈக்வட்டோரியல்? ஈக்வட்டோரியல் வந்து ஸ்லைட்லி ஸ்லாண்டிங்காக வரும். டுவர்ட்ஸ் அப்வர்ட் ரைட், டுவர்ட்ஸ் அப்வர்ட் அப்படின்னு வரும், டவுன்வர்ட்னு வரும். ஸோ அப்வர்ட் டவுன்வர்ட், அப்வர்ட் டவுன்வர்ட், அப்வர்ட் டவுன்வர்ட். புரியுதா? இது வெர்டிக்கலாக போட்டிருக்காங்க, பட் ஆக்சுவலாக இப்படி இருக்கும். ஈக்வட்டோரியல்னாக்கா இப்படி சைடில் வரும், மாறி மாறி வரும், இப்படி வரும். ஓகே, ஸோ திஸ் இஸ் ஈக்வட்டோரியல். ஸோ இந்த ஈக்வட்டோரியல் நான் தனியாக லெட் மீ ஐடென்டிஃபை. டவுன்வர்ட், ஓகேவா, அப்வர்ட், டவுன்வர்ட், அப்வர்ட். இப்படி போடணும், சாரி மேலே போடணும். இதில் கொஞ்சம் தப்பாக போட்டிருக்காங்க ஸ்ட்ரக்சரு, நீ கரெக்டாக போடு. நான் லெட் மீ ரைட் லைக் திஸ். ஓகே, அப்வர்ட், இதை அழைச்சிரு, இல்லாட்டினா நானே போட்டுறேனே. So நீ அந்த ஸ்ட்ரக்சர் போடுறப்ப எப்போதுமே இந்த பார் you can draw like this. You can draw. இங்கே போட்டா இங்கே போடு. ஸோ parallel லைன் வரைஞ்சிக்கோ, கிட்ட கிட்ட வரைஞ்சிக்கோ. You can draw like this. டாப்பில் ஒன்று இப்படி, பாட்டத்தில் இப்படி. Okay. Now this is the hemiacetal. Okay, so this is the oxy linkage, and now you have the carbon here, first carbon. Okay, so first carbon வந்து இப்போ நாம் என்ன பண்ணுறோம், when it is ஈக்குட்டோரியலாக போடுறப்ப நான் என்ன சொல்லியிருக்கேன், முதல்ல வந்து நீ axial போட்டுரு. So first axial, let me draw the axial by yellow line so that it will be very comfortable to you. Downward. Okay, then upward, downward, upward, downward. Okay, அதுக்கப்புறம் என்ன பண்ணணும், you can draw equatorial. So let us draw equatorial. Let me indicate by blue line. Blue line தெரியுதா, இல்லைன்னா ரெட்டில் போட்டா. ஓகே, ஸோ upward இங்கே எப்படி வரணும், downward, இங்கே upward, இங்கே downward, இந்த இடத்துட்ட upward. இப்போ நம்ம பொசிஷன் பண்ணோம். Suppose if you put OH here, let me show OH. So if it is OH on the upper side, then alpha இப்படியே மாறி வந்ததுன்னா பீட்டா இப்படி மாறி வரும். ஓகேவா, ஸோ இந்த இடத்துட்ட இப்படி இஸ் OH here. யூஸ்வலாக எங்கே வரணும், OH இங்கே வரும் இல்லையா, ஆனால் தேர்டில் இட் வில் பி ஹியர், ஃபோர்த்தில் இட் வில் பி ஹியர். ரைட்டில் வரதெல்லாம் லெஃப்ட்டில் வந்துடும், ரைட்டில் வரதெல்லாம் பாட்டம், லெஃப்ட்டில் வரதெல்லாம் டாப், அப்படி வச்சுக்கலாம். தென் இந்த இடத்துட்ட OH இப்படி வருது, CH2OH. ஓகேவா, ரைட். ஸோ இப்படி போட்டாலே போதும். அதர் இதெல்லாம் ஹெச்னு அர்த்தம், ஹெச் 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 அண்ட் தென் ஹெச், இந்த இடத்துல ஹெச், CH2OH. ஓகே, இங்கே ஹெச் வரும், OH இல்லை. அதுதானே, ஓகே. I have drawn the structure here also, I think. இதுக்கு முன்னாடி somewhere I gave you.
Favorite chart structure, sir?
ஆமாம், சேர் ஃபார்ம். சேர் ஃபார்ம், சேர் ஸ்ட்ரக்சர் இல்லை, it is சேர் ஃபார்ம், that's all. Okay.
Okay.
So with this we have finished the structural elucidation of glucose. Similarly, we can derive the structure and establish the structure for fructose also. Okay. So any doubt?
No, sir.
Okay.
No, sir.